Hello everyone. Write down pulley based questions. We've already done questions where pulley is involved in laws of motion, but now you will see involvement of rotational motion. Two blocks M1 and M2 such that M1 is greater than M2. This M1 moves downwards with an acceleration A, M2 moves up with same acceleration A. In laws of motion, we used to say that there is no friction between pulley and rope. I hope you remember this important statement. But in rotational motion, we say that there is, basically we talk about real life situation. Friction is present between rope and the pulley. And because of that, this pulley is also going to rotate. As M1 goes down, you can see that this pulley is going to rotate like this. This will be the rotation. Once rotation is present, we have to deal with moment of inertia. So, moment of inertia of this pulley is I. Radius of the pulley is R. This is R. Now when pulley also rotates, we need to find the acceleration of M1 and M2. Draw the figure and then we'll write few things so that you can easily solve this question. Write down this much first. Write down the statement. There is sufficient friction between pulley and rope. There is sufficient friction between pulley and rope, and because of that, rope does not slip. Rope does not slip over the pulley. In laws of motion, the pulley, there was no friction, and the rope, it easily slipped over the pulley. But right here, you understand it better in this way. Suppose my hand represents pulley and this hand represents the rope. So in laws of motion, it easily slipped, and therefore pulley was not rotating at all. There was nothing which could rotate the pulley. But in rotational motion, we say that there is sufficient friction between pulley and rope, and therefore what happens? This thing is going to rotate. The pulley part is going to rotate. There is no slipping present between pulley and the rope. So, once you say that there is sufficient friction, it means this pulley is not going to rotate. The pulley is going to rotate like this. Now, to find acceleration, we draw what free body diagrams, and those things are exactly same as they were in laws of motion. This is N1G, this is N2G. This is T. This is T. Tension. Away from the body, away from the body, away from the body, and away from the body. T and T. But now, in rotational motion, on both sides, you cannot have same type of tension force. Why not? Look at this free body diagram of the pulley only. If you draw free body diagram of the pulley, this tension force is acting in this direction, T. This tension force is acting in this direction, away from the pulley. This T is acting on M1, this T is acting on M2. These are the forces acting on the pulley. And pulley can rotate about its center. So this is the axis of rotation for the pulley. This is the axis. From the axis, at a distance of R, you have two forces, T and T. Well, I hope you can see that this T, it is giving a torque in this direction. And this T, it is producing a torque in this direction. This is T. And because of this tension force, you have a torque like this. Because of this T, you have a torque like this. But since M1 is greater than M2, this M1 is coming down and pulley therefore is going to rotate like this. If tension on both sides is same, then this torque is going to cancel this torque and pulley will not rotate. That's what happens in laws of motion when no friction is present between pulley and rope. But if friction is present, then tension on this side will be T1, tension on this side will be T2. From this point to this point, tension will be same. Because of the pulley, tension changes, becomes what? T2. Now again, from this part to this part, it's a massless thing and therefore tension will remain same, which is what? T2. Now, if this is T1 and this is T2, this is T1 and this is T2, then torque of T1 is tau 1, torque of T2 is tau 2. Tau 1, tau 2, N1G, T1, M2G, T2. You will understand this tau 1 and tau 2 part in just a few seconds. But let's first write down equation for M1 now. For M1 there are two forces, M1G and T1. And how do we write equations? We take help of F equals to Ma. What is net force? M1G minus T1, which is equal to mass into acceleration, M1 into A. For M1, M1G minus T1 equals to M1A1. याद करो अपन क्या किया करते थे, ये डोमिनेटिंग है, जो डोमिनेटिंग है उसमें से T1 को subtract किया, the other force, this becomes net force, which gives us what? Mass into acceleration. For M2, this M2 is going up, and therefore T2 is the larger force. And therefore for M2 equation will be what? T2 minus M2G equals to M2A. This minus this, mass into acceleration. These are the two equations with the help of F equals to Ma, which is what? Linear motion. What is this? Rotational motion. For rotational motion, we will be using what? Tau equals to I alpha. F becomes what? Torque. Mass becomes what? Moment of inertia. A becomes what? Alpha. What is alpha? This pulley is going to rotate with an angle or acceleration of alpha. The moment you release M1, it starts coming down with acceleration A, and then along with M1 and M2, the pulley also starts rotating with angular acceleration of alpha. That's your alpha. Now, जो काम की चीज है वो क्या है? What is F? Total force. How do you find total force? You subtract smaller force from the larger force. That's what we'll do in this figure also. There are two torques of tau 1 and tau 2. लेकिन कौन सा डोमिनेटिंग है? आपको पता है कि ये पुली कहाँ रोटेट कर रही है? This pulley is rotating like this. And therefore, which one is dominating? So what is net torque? You will write tau 1 minus tau 2 equals to I alpha. जैसा N1 M2 के लिए F equals to Ma है, rotational bodies के लिए tau equals to I alpha. What is tau 1? What is torque? Force multiplied by a perpendicular distance. This tau 1 is what? T1 into R. T1 multiplied by perpendicular distance minus T2 into R. This gives us I alpha. Again, in laws of motion, there was no friction present between pulley and rope, and therefore alpha was not present. If alpha is not present, in laws of motion, if alpha is not present, then this becomes what? 0. That gives us what? T1 equals to T2. लेकिन यहाँ पर रोटेशनल मोशन में ये पुली रोटेट करेगी, इस वजह से दोनों तरफ टेंशन फोर्स सेम नहीं हो सकता. That's your third equation. Now, let's count number of unknowns. T1, T2, A, and alpha. There are 4 unknowns, but we have got only 3 equations. We need a 4th equation, and that 4th equation is again with the help of the statement which we wrote. What was the statement? That there is no slipping between rope and the pulley. What does it tell you? Do one thing first, note down this much, and then I will write the fourth equation. Note down this much first. How do we find fourth equation? This is the pulley which is rotating with angular acceleration alpha. Who can tell me what is tangential acceleration of this point? What is tangential acceleration of this point on the pulley if pulley is rotating with an angular acceleration of alpha? If you can answer this, answer in the comment box. What is the tangential acceleration of any point on the circumference of the pulley? Good. This is coming from circular motion. This point has a tangential acceleration of r alpha. We used to write at equals to r alpha. Small t for tangential. This is tangential acceleration. If any body is rotating, then tangential velocity is what? We use v equals to r omega, and then when you differentiate it, we get a equals to r alpha. So this is acceleration of this point downwards. But I told you that this rope is also not slipping. So the point which is in immediate contact with the pulley, point of the rope, let's show it with blue dot, if you can see the blue dot. This is the part of rope, and this blue dot is in contact with the black dot. The black dot is part of the pulley, which is like this. So my hand is a pulley. So let's say this thumb is part of the pulley, and now this is rope. So this thumb is touching the other thumb, and they are not slipping. If they are not slipping, then it means they both have same acceleration. This point, its tangential acceleration is what? R alpha. But this point is also touching the point of the rope, and they are not slipping against each other, which means they have same acceleration. But what is acceleration of M1? A. And therefore every point of the rope is having same acceleration. That tells us what? This AT and this A, they are same. AT tangential is same as A of m1, which is r alpha. Statement or the equation is valid only if they say that there is sufficient friction between pulley and rope. When I say sufficient friction, it means no slipping can take place. If rope slips over the pulley, then this equation is not valid at all. All these equations will be correct, but this one will not be correct. So you've got four equations, four unknowns. How do you solve them? Well, look here. This is minus T1, this is T2. If you add these two, you get what? T2 minus T1. How to solve four equations? T2 minus T1, when you add these, take R common, bring it over here. It becomes what? T1 minus T2. So you got the same thing, which is coming from this side. You can put it over here. You can find T1 and T2, and once you find T1 and T2, replace alpha with what? A upon R. This is alpha, make it A upon R. Put these values in this and you will get your answer. Look how easy it is to solve all these equations. In just one line, we can answer, we can find the acceleration. What is this? T1 minus T2 equals to I divided by R. Take R common, move it here. What is alpha? A upon R. Make it A upon R. Now do what? This plus this plus this. What is this? T1 minus T1. T1 minus T1 gone. T2 minus T2 gone. On the right side you've got A, and A. Take A common, and when you take A common, your final format will be this. When you add all these equations, you are left with what? M1G minus M2G. M1G minus M2G. And on the right side, you've got A, M1 plus M2 plus I upon R square. This gives us acceleration A as m1 minus m2g divided by m1 plus m2. In laws of motion, this was the acceleration. If you remember the result of acceleration in laws of motion, that was the answer. In rotational, you are adding the term of I upon r square. So now it becomes a trick. How can you remember this acceleration? m1g minus m2g. This is the net force. Net force divided by total mass m1 plus m2. What is mass equivalent of pulley? I upon r square as a trick. In laws of motion, pulley does not rotate, and therefore we are not dealing with I. Forget about I. This is the answer in laws of motion. This is the answer in rotational motion. put the whole thing inside a boundary like this and remember this as a result. If you understand everything, then write down yes in the comment box. If you are confused, then tell me what your confusion is. One of you is asking how tangential acceleration is equal to acceleration A. First of all, forget about pulley. In circular motion, we used to say that if an object is rotating with angular acceleration alpha, let's say this is the object, a point mass, and the point mass is rotating with angular acceleration alpha, then tangential acceleration is r alpha. This is coming from circular motion. You have a point mass which is rotating like this. Now, this is circular motion. Now, in rotational motion, what we have done, this is the pulley, and this is the rope. That's your pulley. And this is your rope. और यहाँ पर अपना एक ब्लॉक कनेक्टेड है. It was M1. The thing which you see in blue is the rope. And the thing which you see in black is the pulley. And if I say no slipping takes place, If it doesn't slip, then it means what? Any point on the rope and any point on the disc, the nearest point, the point which is at the circumference, so this point of the disc and this point of the pulley, they are touching each other. There is no slipping because friction is sufficient. Which means this and this, if I say that this marker is moving along with my hand and no slipping takes place, then it means they both have what? Same acceleration. So this blue point and this black point, they have same acceleration. We have the acceleration of black point because it is doing what? Circular motion. So its tangential acceleration is what? R alpha. We have the acceleration of blue point. This blue point is part of the rope. If M is coming down with A, then this blue point is also coming down with A. And the black point is coming down with tangential acceleration AT. Because of no slipping, AT is A, which is R alpha. Hopefully you understand it. In laws of motion, after M1 and M2 in this format, we had a table, and on top of the table was M2 and M1 was hanging. Like this. So it's a frictionless table. There is a pulley. There are two blocks. M1 and M2. There is no friction between M2 and the table, but there is sufficient friction between pulley and rope. Remember, no friction, sufficient friction. Moment of inertia of pulley is I, its radius is R. Find out acceleration A. You've got around 1 minute's time. Let's see if you can answer this. We can write the answer without using any equation. If this question is asked in an objective examination, you don't have to draw anything. In just one line we can answer this. We'll learn that part also. But right now I'm interested in all the equations, all the required equations coming from laws of motion and rotational motion. So give it 1 minute's time, write down all the equations, and then when I present the solution, find out whether you did everything correct or not. Look, how do you form equations? Downward force is N1G. This is T1. This is also T1. But this is T2. This is also T2. From this place to this place, tension will remain same. From this place to this place, tension is going to change because of sufficient friction. Tension acts away from the body, away from the body. This is the body, away from it. This is the body, away from it. If M1 is coming down with A, this M2 is also moving with same acceleration A. So what is the equation for M1? M1G minus T1 equals to M1A. First, this minus this, mass into acceleration. For M2, there is no role of M2G. Your M2G hai, that is being balanced by the normal reaction. What is the force on M2? Only T2. T2 equals to M2A. What about pulley? This time round, that's how forces are acting. This and this, that's your T1 and this is T2. What are the distances of T1 from the axis? This is R. This is also R. Now this is the axis, that's your force. Force. What is the perpendicular distance? R. For this T2, same thing. That's your T2. This is the axis. What is perpendicular distance? R. And what are the signs of rotation? For T1, that's your tau 1. For T2, that's your tau 2. That's the axis. ये T1 ऐसे लाना चाहता है, and T2 इस तरफ. But which one is dominating? If M1 is coming down, then this pulley is going to rotate like this with an acceleration of alpha, angular acceleration. Which means which one is dominating torque? Of T1. Write down that T1 into R minus T2 into R equals to I alpha. Exactly same equation. It doesn't matter if T2 acts here, right here, or at this place. Torque wise, you are getting the same equation. No slipping gives you A equals to R alpha. So those of you who made these four equations exactly like this, write down yes in the comment box. If you develop these four equations, then write down yes in the comment box. Only two. One has got the correct answer and the other one is saying yes. Now, how do you find acceleration for these things in just one line? First of all, divide by R, replace alpha with A by R, add all these things. But For an objective examination, remember the trick. What is the pulling force? M1G. What about M2G? बताया मैंने. Normal reaction उसको संभाल रही है, अपने काम का नहीं है. What is the pulling force? M1G. Now this M1G is pulling how much mass? M1, M2. Force divided by mass is what? Acceleration. यहां तक का आंसर आया करता था लॉज ऑफ मोशन में, जाकर देख लेना. As a trick or whatever you say, in rotational motion, पुली का जो मास इक्विवेलेंट है is I upon R square. Done. इतना इजी है आंसर प्रोड्यूस करना. Method is also not that difficult. देखना कितनी इजी है ये चीजें. Let's see how many of you will answer this part. देखना भाई. This is 37 degrees. This is 30 degrees. This is 4 kg. This is 8 kg. Pulley has a moment of inertia of 20. Its radius is 2. Friction is 0. Friction is 0. Sufficient friction. Find out acceleration. No friction between 4 and the triangular wedge. Between 8 and triangular wedge, no friction. Sufficient friction between pulley and rope. Find out acceleration of 4 and 8. Should not take more than 1 minute. And you don't have to write any equations. I want a straightforward answer like this. Think about it. How to use this equation. आपका कॉन्फिडेंस बढ़ेगा. ट्राई करना, बहुत इजी चीज है. one response. Okay, take the hint. What is the force which is pulling this 4 kg along the incline? mg sine theta. Along the incline क्या component काम करता है अपना mg sine theta, which is 4 into 10. Theta is 37. What is sine 37? 3 by 5. This is coming 5, 2, 8, 3, 24. What is the component in this direction? M G sine 30, which is half. This is coming 40. M G sine of this angle. So which one is dominating force? This 40. ये 40 इधर खींच रहा है. What is the acceleration? 40 minus 24. This 40 is being opposed by 24. That's the net force. Divided by total mass 8 plus 4 plus I upon R square. जो अपनी पुली है उसके लिए I कितना है? 20 divided by R square, which is coming 16 upon 12 plus 5, which is 17. Done. केवल इतना करना था. 16 by 17. Only one got the correct value. All others, do you understand the question now? Yes or no? Well, I was expecting that many will answer this question, but only one could produce the correct value. It doesn't matter you have an inclined surface or you have flat surface, horizontal surface, or both blocks hanging vertically. What is the theme? Find out net force, divide by total mass. Done. And even if friction is present between block and the wedge, even then there is nothing difficult. If friction is present, then what you will do? You will find what? Frictional force, which is what? Mu mg cos theta. So if the whole thing is coming down this way, then friction will be acting in this direction. This is going up, friction will be acting down the plane. Use the effect of friction. Same method, same everything. This is rotation. Now let's talk about rolling. Write down the heading rolling. What is rolling? What is the difference between rotational motion and rolling? A ceiling fan, it rotates, whereas car tire, tire of a bike, tire of a bicycle, it rolls. That is simple difference between rotational motion and rolling. This is rotation. This is rotation. This is rolling. रोटेशन, आपने अपनी बाइक को स्टैंड पे खड़ा किया और टायर अपनी जगह पर क्या कर रहा है? रोटेट. रिमूव द स्टैंड, accelerate it, it starts rolling. That's the difference between rotation and rolling. Now, what is rolling? This is rolling. That's ground or a surface on which your body is going to roll. This is what is going to roll. A wheel, a disc, a circle, sphere, can be anything. So in rolling, what is present? In rolling, you have the body moving forward, at the same time rotating with angular velocity omega. In rolling, what happens? Thing is also moving forward. So it is coming in this direction, at the same time it is rotating. So you have V present, you have omega present. This will be your center of mass. We say that center of mass is moving with V and it is rotating with omega, which is equivalent to this, as if somebody has superimposed translatory motion over pure rotation. आएगा समझ में? क्या बनाया अपन ने यहां पर कि जो बॉडी थी अपनी, this thing, this bottle, when it rolls, we can break this rolling into two parts. One is that every part of the bottle has a translatory motion. Every part, no rotation is present. This will be called pure translatory motion. Pure means no rotation is present, like this. Plus, if you have only rotation present, pure rotation, no translatory part. So if you superimpose this over this, you get what? Rolling. So feel करने का एक दूसरा तरीका भी सोचेंगे अपन अभी. But as of now, this is rolling. Which is sum of pure translatory motion and pure rotational motion. First note down this much and then I'll explain the rolling part once again. By the way, those of you who understand that rolling is a mix of pure translatory and pure rotational, if you can feel it, then write down yes in the comment box. If you are comfortable with the mixing of translatory and rotational, then write down yes in the comment box. Look, let's see if you can answer this part. कोशिश मत करना लेकिन फील करना, ट्राई करने की कोशिश मत करना, आंसर देने की कोशिश करना. सपोज आप बाइक पर हैं अपनी, आप बाइक पर बैठे हुए हैं. सपोज आपका फ्रेंड बाइक पर है और आप पीछे बैठकर चल रहे हो उस पर. इफ यू लुक एट द व्हील, देन व्हाट टाइप ऑफ मोशन विल यू सी? लेट मी रिपीट माय क्वेश्चन. You are on a bike or you are inside a car, and if you could see the wheel inside, from the inside of the car, if you could see the wheel, let's make a transparent car. So somebody from the inside of the car looking at the wheel, what type of motion does he see? Rolling, pure translatory or pure rotation? Answer this part. It will develop the feeling. Somebody on the bike, if he somehow looks at the wheel, then what does he see? Rolling or pure rotational motion? What do you think? Good. We'll only see what? This. Why not this? Because along with the car or the bike, you're moving in the same direction. And relative motion tells us what? As an observer, you are at rest. बाइक आपकी जा रही है V से, आप भी उसी पर बैठे हो, तो आपको जो बाइक का एक्सल है, जो व्हील का एक्सल है, वो आपको आगे जाता हुआ दिखाई नहीं देगा. आपको व्हील केवल क्या करता हुआ दिखाई देगा? रोटेशनल मोशन. But at the same time, if you ask an observer who is standing by the side of the road, if you ask him, what type of motion do you see? He will say that he sees rolling. Write down this. If an observer inside a car, if an observer inside a moving car looks at the wheels, then he will find only rotational motion. But at the same time, an outside observer, will find rolling in the same wheel. Now, once you visualize this part, अब ये चीज क्या है हमारे लिए यहाँ देखो. What is V? Velocity of the center of mass. So this wheel, when it moves with V, we are going to say that every point, this, every point is moving with what? Same speed V. In rotational part, remember this is pure rotation. And this is pure translatory. And this is rolling. Now who will tell me velocity of this point? What is the velocity of this point along with the direction? Write down this in the comment box fast. What is the velocity of this point? Should not take more than 5 seconds. What is the velocity of the lowest point? Good. The velocity of this point is what? In this direction. And what is this? What is the radius? R. And what is this? Pure rotation. In pure rotation, what is tangential speed? R omega. So this is your R omega. Backwards. This is also R omega. This is coming from what? Circular motion. Every tangential point is moving with R omega. This is V, this is V. Now will tell me what is velocity of this point in rolling. What is velocity of this point, contact point? Lowest point of the wheel in rolling. What is velocity of this point? Look at the figure on the right side and you can answer this question. Look at the arrows. Look at the arrows. Now that's the correct answer. Translatory motion says this point is moving with V forward. circular motion or rotational says this point is moving backwards with r omega. So what is net velocity? Net is v minus r omega. This is velocity of the contact point. Velocity of the contact point is what? V minus r omega. V minus r omega. Now answer this. What is velocity of the highest point? What is velocity of the highest point of the wheel? Good. V superimposed over r omega. They both are in the same direction and therefore highest point is moving with v plus r omega. V plus r omega. Now let's see who answers this. What is the velocity of this point? This. Well, one of you got it correct. Good. What is V? Velocity of the center of mass. Velocity of the center of mass means every point is moving with V. Any point you take on the body has to move with V. That's the meaning of center of mass. If I say that this racket is moving with V. As it moves with V, every point which lies on the racket is moving with what? V. So, this point is moving with V, but rotational motion tells us that, or say circular motion tells us that this point is moving tangentially in this direction with r omega. R omega. And therefore, this r omega is also present. Now you've got two vectors which are mutually perpendicular. So what is the total velocity? Root over v square plus r omega square. And that vector sum will be in this direction. So this arrow, blue arrow, is your root over v square plus r omega square. Vector sum. Now, कितना easy है इस चीज को visualize करना? Any dust particle which leaves the tire, they can ask, in fact, can ask you a question like this: a dust particle right here leaves the wheel. So, in which direction it is going to move? Horizontally, vertically, or like this? The answer is that this dust particle, which is at the circumference, at the rim of the wheel, is going to move like this. And to protect you from this dust particle, we have what? A mud guard over here. which protects us from this. Now I hope everybody can answer. In rolling, what will be the velocity of this point? We have found velocity of this point is in this direction. If I take a point over here, then again same thing. This is moving in this direction with V, coming down with R omega because of circular motion, and resultant will be in this direction. What is this resultant? Root over V square plus R omega whole square. And similarly, you can find velocity of any other point on the circumference. Note down this much. Now write down pure rolling. This was rolling, and now pure rolling. Write down what pure rolling is. Pure rolling means rolling without slipping. Pure rolling means rolling without slipping. Without slipping means, look at this contact point. If it slips back on the forward direction, then that will be rolling only. When I say pure rolling, it cannot move, it cannot slip over the contact surface. So in pure rolling, no slipping takes place, which means, write down this, that is, velocity of the contact point becomes zero. That is, velocity of the contact point becomes zero. In fact, in normal life, whenever a bike or a car moves, that is pure rolling. No slipping takes place. और भी अच्छा example, जब आप चलते हो, when you move, basically in the pure rolling mode. आपने notice किया है, friction में करवाया था मैंने, कि जब आप चलते हो, तो जो shoe आपका ground के contact में होता है, that doesn't move. Look, body when it moves, it's basically in the rolling part. These are the two legs. As it moves, so the shoe which comes in contact, it no longer moves. The other one, it moves, and then when the other shoe comes in contact, that comes at rest. The first one now starts moving. So the kind of motion you see is something like this. These are the two spokes, which are nothing but your legs. ये यहाँ पर contact में आया, the other one which is in the air, it's moving. When it comes in contact, it comes at rest. It no longer slips. The other one, it moves. When this one comes in contact, your whole body is basically in what? Rolling. What type of rolling? Pure rolling. What is pure rolling? When contact point does not slip. If it doesn't slip, आप अलग से बनाना, मैं इसी में कर दे रहा हूं. If it doesn't slip, then V minus R omega is what? Zero. V minus R omega 0 means V is R omega. So if you have V equals to R omega, then what happens? Pure rolling. Now tell me one thing. In circular motion we know that V is always R omega. लेकिन अपन यहाँ क्या बोल रहे हैं? If V is R omega, then takes place pure rolling. लेकिन अपने को circular motion से पता है that V is always R omega. So we can remove this confusion. For pure rolling, I am saying that V must be R omega. Must be means it may not be in certain cases. But in circular motion, we know that V is always R omega. So what is the problem? What is the confusion? How do we remove this confusion part? Let me answer this. What is V? Velocity of the center of mass. So if you have a wheel like this is a wheel. Look at this, only this part. What is V in this case? When I say V means what? Velocity of the center of mass. In this situation, center of mass has no velocity. In circular motion, V is always R omega. Which V is that? Tangential. Even in this case, every tangential point is moving with R omega. But what is the velocity of the center of mass? 0. So, when you say V equals to R omega gives you pure rolling, remember this V is velocity of the center of mass. जब ये आगे भी जाए इस तरह से V डेवलप हो कि वो इस R omega को कैंसिल कर सके, and if that cancellation takes place, your contact point comes at rest, which gives us pure rolling. So write down this part. If velocity of the center of mass is equal to R omega, then contact point does not slip, which is called pure rolling. Now just last 1 minute. Who can give me the kinetic energy of the wheel which is moving with V and rotating with omega? Can you give me kinetic energy of this wheel? I am giving you just 30 seconds. Who can tell me the kinetic energy? And everything is in front of you. Look, I need kinetic energy of this, which is what? This. What is this? Translatory. No rotation, only what? Translatory. Translatory means how much kinetic energy? Half mv square. A body is only moving like this. That's the kinetic energy. And what was kinetic energy in rotational motion? How did we write kinetic energy in rotational motion? That was half of I omega square. So this is the kinetic energy during rolling. That's why we have introduced concept of pure translatory and pure rotational. Rolling is mix of these two, which gives you total kinetic energy. And this is rolling. If they say pure rolling, हमारा जो V है वो क्या बन जाएगा R omega. Listen again. What is this V plus R omega? कब? हमेशा. अगर pure rolling है, then V plus R omega will be what? 2V. This will be what? 0. जहां आपने प्योर रोलिंग वाला फिगर बनाया हुआ है, जहां आपने 0 किया हुआ है, over there you can write like this 2V. This thing will become root 2V. You can replace omega with V or you can replace V with omega, provided it is what? Pure rolling. If it's not pure rolling, you're simply adding two terms of half mv square and half I omega square. Note down this much and then you can leave. Thank you very much.